Okay, this is a video on the first part of 5.2 and starting to explore exponential growth and decay. So this first example is a very typical one about interest. And some banks give you interest and calculate your interest on an annual basis. Other banks give you part of your interest more often, say, for example, on a quarterly basis, 4 times a year, a monthly, or even daily, and so on. So here's the initial part of the problem. Let's say you deposit $1,000 in a Wells Fargo savings account on your 16th birthday. The bank account gives you a 3% interest rate, and advertised interest rates are always on a per year basis, by the way. So this would mean 3% per year, and consider the following. How much money will you have after 1 year if the bank calculates the interest at the end of the full year the account, end of every full year the account is opened? Okay, so you start off with 1,000, and then you're going to earn 3% on that 1,000. So your interest will be 0.03 of 1,000. Or in other words, if we factor out 1,000 here, it's going to be 1 plus 0.03, or it's 1,000 times 1.03. And that's going to be equal to 1,030. All right, let's see how we can use this process to figure out after 3 years. So we just said after 1 year, it is 1,030, or it was 1,000 times 1.03. Well, after 2 years, so remember this was 1,000 times 1.03. After 2 years, it's going to be the 1,000, what I started off with, times 1.03 times 1.03 of that. Or another way to see that, if that is confusing, is if I'm starting off with 1,000 times 1.03, well, I'm going to add to that 0.03 times that 1,000 times 1.03. And if I factor out the 1,000 times 1.03, that's going to give me that times 1.03. So in other words, after 2 years, it would be 1,000 times 1.03 squared. So thus, continuing in the same way, after 3 years, it's going to be 1,000 times 1.03 squared times 1.03, or in other words, 1,000 times 1.03 to the third, which ends up being about 1,092.73. Well, let's generalize this. Using the same process, we can say, how much money will you have after n years? Well, I'll have 1,000 times 1.03 to the n. Okay, so now let's say that the bank pays you a portion of the interest every 3 months, or 4 times a year. This is called compounding the interest quarterly. How much of the 3% do you think you'd get? Well, given the 3% is an annual, then if I'm dividing it up into 4 times a year, I'm going to get 1/4 of 3%, or 3/4%. All right, given your answer to part E, calculate how much money you would have in the bank after 3 months if your interest is being compounded quarterly. Well, 3/4% is going to be 0.0075. So I'm going to have 1,000 times 1.0075. Because that's after 1 3-month period there, and that's 1,007.50. How much will you have after a year? Well, after a year, I'll have 1,000, 1.0075. Well, how many of those 3 months are in a year? 4. So I will have about 1,030.34. What about after 2 years? Well, after 2 years, I'm going to have how many quarters? Well, that will be 8 quarters. So it's going to be raised to the 8th, and that's about 1,061.60. Finally, how much would I have after 10 years if compounded quarterly? Well, 10 years would have 40 quarters, so 1,000, 1.0075 to the 40th, which is about $1,348.35. Oops, 0.35. These are all dollars. Okay. All right, so let's try another situation, and then we're going to generalize here. So in this case, some banks compound once a month. How much of the 3% do you think you get if it is compounded monthly? So if 3% again is always reported as the annual, well, if I think about monthly, 1/12 of 3% is 1/4%, or 0.0025. So give your answer in part I. Given your answer in part I, calculate how much money you would have after 3 months of having your month compounded monthly. So 3 months would be 1,000. This rate of 0.25%, and that's going to be 3 months of that. So 1,007.52, about that. All right, given your answer to part I, calculate how much money you would have after a year. Okay, so after a year, that would be 12 months. So 1.0025 to the 12th is about 1,030.42. Now, it's asking us to compare this to my answer in part F. Well, if you look back at F, if I compounded for 1 year quarterly, I was slightly less. I was 1,030.34, so it is slightly advantageous to compound monthly. And you can imagine it might be more so the longer I keep my money in, then it would be more advantageous to compound it monthly versus quarterly. Okay, how much money would you have after 2 years? So 2 years, we're talking about 24 months. So it'd be 1,000, 1.0025 to the 24, and it's about 1,061.76. Finally, 10 years. So 10 years will be 120 months. Whoops, 1.0025. And that would be 120 months, and you should have gotten about 1,349.35. Okay, so finally, let's generalize. So I'm saying here, and this is not me making it up, these are the variables that are used. Find a function a of t that gives you the amount of money that a particular investment is worth after t years, based on an initial amount p, so p is your initial amount, a certain annual interest rate, R. Sometimes the initial amount, P, is the principal, or sometimes it's also thought of as the present value. So your annual rate is always designated as R, and the number of interest compounding periods is N. So for example, if it was monthly, N would be 12. If it's quarterly, N will be 4. If it's daily, 365. Well, what we did is we did the principal, and then we did 1 plus the annual rate. And remember, this is going to be as a decimal. And then we divided that by the number of compounding periods, whether it was 4 or 12, those are the two we did. And then it's going to be the number of years t times n, the number of times compounded per year. Okay, so that is the formula for, we call this the compound interest formula.